Hi everyone, I want to welcome you to the case 2 of this video series. Now, if you remember, we started with case 1. Let me just quickly scroll up. This is where we started with, and we were able to look at case 1, how we got the perpendicular or normal component of the force. So in this video, we'll be looking at the parallel, also known as the horizontal component of the force. That's the f subscript p rather. So how do we determine f subscript p? Now don't forget, in the first video I talked about, I said we are going to be doing all these two forces, that's fp and fn, with respect to what fg, which implies that fg is our major focus, and theta here is the what is our focal angle, right, or our reference angle, as the case may be. Don't mind all the English I'm using. So in this case, we are focusing on fp and fg. So our focus here will be fp, right? So we are focusing on fp and f subscript g. So if you want to do that, if you want to do fp and fg, what would that be? Now let me quickly scroll up so that you see. Now fp here is opposite, and fg here, f subscript g rather, is what? Hypotenuse. So opposite over hypotenuse here is what? So don't forget, so implies what? Sine theta. So we can say this implies that so so is what? Opposite over hypotenuse. Now opposite, this also implies that sine theta, because theta is equal to what is our opposite? Our opposite there is what? F subscript p. I'll show you. Over hypotenuse, f subscript g, right? But because we are looking for fp, that's the parallel component, so we can say this implies that f subscript p is equal to what? F subscript g, right? Sine theta, right? Don't forget, recall again, though we've done it in the first slide, that f subscript g is the same thing as weight, that's force due to gravity, which is equal to mass times what? Acceleration due to gravity, which is g. So this implies that f subscript p is equal to what? Is equal to what? Mg, right? Sine theta. So we can call this equation 2. I said I was going to show you how I got fp over fg. Look at it. Opposite over hypotenuse, fp over f subscript g. So that is the logic. So in this case, we have fp is equal to mg sine theta. So we can quickly do case 3, because actually what we are looking for is the coefficient of static friction, right? You now recall generally we have the coefficient of friction, coefficient, right, of friction. Now coefficient of friction is given by mil. It's got to frictional force over normal reaction. I use r, which is the same thing as n in f subscript n. So this implies that we can say coefficient of static friction is equal to force of static friction over over normal reaction, right? So for object, right, inclined, for an object inclined, right, force of static friction is the same thing as force that is parallel to the plane, and normal reaction is the same thing as force normal to the to the plane. So this implies that we can say coefficient of static friction is equal to f subscript p over 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 f subscript n, right? Now we are going to make some recall. Let me put comma here. Recall again. Recall that from equation 1, we have that from equation 2, which is this one, we have that f subscript p is equal to mg what sine what theta. And from equation 1 we have that f subscript n is equal to what m what g, right, cos what theta, right? So if you plug in fp and fn into this equation, let me scroll up a bit. If you plug it into the equation, we're gonna have um what coefficient of static friction. Coefficient of static friction will now be what mg sine what sine theta over what mg what cos theta. So mg cancel what mg here, so this one will give us what sine what theta over what cos what theta. You need to recall from your knowledge of trigonometry, recall that sine what sine theta over what cos what theta is equal to what tan theta. So this implies that coefficient of static friction is equal to what tan what theta. So whatever the angle is, the coefficient of static friction. So we can summarily say that for what for object inclined, right, at a what particular what angle to what to the horizontal, right, then the coefficient of static friction is equal to what tan what theta. So you may not actually need to go through all these mathematics involved and the likes. So that is the idea of what coefficient of static friction for what an object inclined. So in the next video I will show you the summary of everything I've done here, then so that you can really understand the general summary. I hope this video helped. Please try and share this video. I want you to subscribe to my channel for more videos.